Hello friends, welcome back. Hearty welcome to you. Let's look at this example. We have to find the sum of all zeros of an algebraic expression, which is x square minus 5x plus 5 whole to the power of x square plus 4x minus 6t is equal to equation. So this is the equation we have. We have to find out all the values of x which satisfy this particular equation. So now let's think a little bit and see what I should have on the left hand side so that the value will be equal to 1. I see that there are couple of options. One is I can get 1 when a power 0 is equal to 1, or the other option is I have 1 to the power of some value is equal to 1. So we can get right hand side one value when the power is equal to 0 or the base is equal to 1. So these are the only two options through which I can get right hand side value equal to 1. So let's take the first one. A power 0 equal to 1, that means the power should be equal to 0. So can I say x square plus 4x minus 6t should be equal to 0. In that case we will have x square minus 5x plus 5 whole to the power of 0. Anything to the power of 0 is equal to 1. This is one solution. The other one will be we have 1 to the power of anything equal to 1. So in that case the base x square minus 5x plus 5 should be equal to 1. So these are the two options we have. So we have to think in this direction. We have been given that right hand side equal to 1, so that will happen only when any value to the power of 0 is equal to 1 or 1 to the power of any value is equal to 1. So in the first case the power whatever we have here x square plus 4x minus 60, that should be equal to 0. And in the second case, when we take 1 power anything is 1, x square minus 5x plus 5 should be equal to 1. Now we will try to split the middle terms here. X square plus 4x minus 60. So I'll write down sum equal to plus 4 comma product equal to minus 60. So what will be the options we have? Plus 10 comma minus 6. 10 into minus 6 is minus 60. 10 minus 6 is 4. So I can write down x square plus 10x minus 6x minus 60 equal to 0. And if I simplify that, I will have x into x plus 10 by taking x common. Here I will take negative 6 common. I will have x plus 10 equal to 0, or I have x plus 10 into x minus 6 equal to 0, which gives me x values are minus 10 or 6. X values are minus 10 or 6. Okay, now let's go to the second. This is the values we got from the first scenario. Now let's look at the second scenario. In the second scenario we have x square minus 5x plus 5 equal to 1. Can I write it as x square minus 5x plus 4 equal to 0. I see sum equal to minus 5. Sum is equal to minus 5. Product equal to 4. So can I take them as minus 4 comma minus 1, so that sum is minus 5 and product is also equal to 4. So how this equation we can change it now, splitting the middle terms. X square minus 4x minus x plus 4 equal to 0. If I skip one step, I can write it as x into x minus 4 minus of x minus 4, or I can say x minus 1 into x minus 4 equal to 0, or from that I am getting x equal to 1 or 4. This is what we are getting, x equal to 1 or 4. Here we got x equal to minus 10 or 6. Now what we have been asked? We have been asked to find out the sum of all the zeros. That means all x values we have to add up. So what are the values we have now? Minus 10 plus 6 minus 10 plus 6 then plus 1 plus 4, so plus 4 plus 1, so 10 and 10 will cancel, answer is 1. So the sum of all the zeros of x square minus 5x plus 5 whole to the power of x square plus 4x minus 60 equal to 1 is nothing but equal to 1. So let's summarize this. We have been given that x square minus 5x plus 5 whole to the power of x square plus 4x minus 60 equal to 1. This will happen only when a power 0 equal to 1 scenario or 1 to the power of any value equal to 1. If you take the first scenario, the power x square plus 4x minus 60 should be equal to 0. If you take the second scenario, x square minus 5x plus 5 should be equal to 1. So we can find out the x values correspondingly. We found them as minus 10, 6, 4 and 1. You just sum them up. We will get the sum of all the zeros is equal to 1. That's an interesting SAT problem. So thanks for your time and support. I'll catch you once again with another interesting example. Bye for now.